of the list of heart rates. Now, there's a couple of ways I like to do this. They both involve using the Boxplot feature. There also, you could go to StatCalc 1 and get you your 5-number summary, but I like to get a sense of the visual also. So this has the previous settings on it, so let me just adjust real quick. All right, so stat edit. You got some data in there from like the second week of classes for some reason. It seems to like to hold on to that information. It must have been like a save point or something. So I put in my data. Little error there. Take care of it right away. Do a quick double check, because for these kind of questions, if you're going to mess it up, this is where you're going to mess it up. If you're iffy on calculator steps, then what I'm about to show you is something that you're going to want to put on your 3x5 note card. Remember, it's a 3x5 note card. It's not open notes this time. As much as we want it to be. Made that mistake one semester. Took all the exam questions from like old tests and reviews, but then I made the final open notes, so nobody did any work. They just copied the answers down from answer keys and like, oh, okay, lesson learned. So, I mean, I'm sure you would enjoy that, but doesn't really.
It was helpful. It allowed us to like check what we did.
Yeah.
Back and forth, try to figure out.
Yeah.
I liked it.
All right, so. Yeah, every now and then. So, okay, so we're going to create the box plot. Now, the box plot, you're going to use the StatCalc feature. Right? Again, there's no, like, unless I missed it, there's no, like, paper roll that's stored inside your calculator where you can actually print a graph. So, you would still need to reproduce this on paper, but it'll give you everything you need. So, the way we do it is we hit second, y equals, we turn plot 1 on. It most likely is on already, just probably not to the setting that we want. All right. Then I go down to type. And this is going to be a 2-for-1 kind of situation. We have 2 different types of box plots. We have this one with the 2 little dots after it, and then we have the ordinary box plot. All right. I'm going to graph them both one at a time. All right. So I'm going to graph this one, which is the modified box plot. So zoom 9 is the stat zoom. And I get this graph, right? Now, I have this stray little bit of curve here. That's because I have some function from another class in here in my y equals. So if you ever get a stray little bit of business here, go into y equals and clear out whatever's there, and then go back to graph. All right, so this is the modified box plot. It's very important that we talk about this because when people mess this up on a test, on the final, it's because they put the wrong kind of box plot. So I'm going to put that there, and then I'm going to go and get the ordinary box plot, and then we'll talk about the difference, because you'll need to know the difference. So second y equals brings you back into your stat plot. So second y equals, enter on plot 1, it's on, hit the down arrow to get you into the type, hit the right arrow to get to the one that you want, and then hit enter. Once you've done that, make sure it's pointing to the right list of data. I put all my data in L1, and each one of those values I put in once. All right. So I'm looking at the ordinary box plot. So I'm going to do a zoom 9 again. All right. It gives us, this is a emulator issue. This won't show up. This little line segment won't show up on your calculator. So I'll just show the relevant piece. All right. So we have two graphs, and if you match them up so that they correspond to one another, you see that structurally they're very similar. The box is situated the same way. They both have roughly the same length, or at least it seems that they do. I get this schmutz here that we don't need. It's distracting. Okay. The first one is called a modified box plot. It shows outliers. All right. The second one is the ordinary box plot. All right. So the directions here are telling us to create box plot, because for some reason I didn't put a preposition. I don't know. Create a box plot. The following list apart, create same piece per minute, and then show the 5-number summary. All right. So you look at it and say, well, we got two types of box plots. Which one is the right one? Well, one is the modified box plot. This is the ordinary box plot. So I want the box plot. All right. So that's what has to go down on paper. But what I like to do is, especially when it comes to a question like in B, where it says determine whether each of the data sets contains outliers or unusual values, is I like to plot the modified box plot first to see if there are any outliers. And oftentimes, what I'm going to get is the box plot itself. Because if there are no outliers, then it'll just display this graph. Right? So it's a good place to start, because when I get to number 2, if I grab class 1 and I don't have a stray dot somewhere, or box mistake, then I'm looking at a set of data that has no outliers, but I would also have everything I need to create the box plot. Right? So it's a little bit of extra, I wouldn't call it work, it's extra steps that maybe you don't want to deal with, but it pays off. All right? And for you today, it'll pay off immediately. Now, how do we get the points? Hit the trace key. All right? So trace, and then hit the left and right arrow to get what you need. All right? So we got a min, a Q1, a med or a median, a Q3, and a max. All right? So I'm going to go lowest to highest and indicate those values. I want to make sure I have them down on paper. Min, Q1, median, Q3, and max. I also like this method because I honestly, when I say this, it sounds like I'm making fun, but I'm not. On the test for this unit, and it wasn't just limited to this semester, the question asked you to create a box plot and indicate the 5-number summary. So what did people do? They created a box plot, or what they thought was a box plot. And how did they do that? They drew a box with some lines and stuff, all right, and called that the box plot. It was evident from their work that they did not look at a graph at any point, or even bother constructing a graph. And the reason behind that is because they forgot. They forgot how to make the graph. And so they needed to grasp at straws and figure, okay, well, I got to do something, so what am I going to do? So they just drew a box with some lines and called, okay, that's my graph. Wonderful job, yay. I'm sure I'll get some credit for that. You didn't. All right. Then they're like, okay, I need a 5-number summary, so what do I do? I don't know, but we seem to be doing this StatCalc business a lot. So they'd go into StatCalc 1. Well, I don't have any I don't have the right kind of, let me just do something meaningful. Oh, I did 1 bar stats. L1, L2. Let me do that. Just L1. They would do this calculation and then just write down the first 5 numbers they saw and be like, well, that's the 5 numbers. Well, I mean, and by definition, sure, it probably is. It is a summary of 5 numbers. I got 5 numbers, and yeah, it's summarizing something, but it's not what I'm looking for. If you use this technique, the idea of going into the graph, the second y equals, select this, the Boxplot function, and then do a zoom 9. That's zoom stat. If you do that and then hit trace, and then the left arrow and the right arrow, those numbers that come up, those are the 5 number summary. All right, you can't go wrong at that point.
And then I go take a picture, and I did StatCalc, and then 1 bars, and then I took down the min, the Q1, the medium.
You scrolled down and got those numbers?
Yeah,
Perfectly fine.
And I just I didn't select anywhere, I just kind of drew it out 25, 50, 75, and I drew it myself.
Yeah. Yeah, that's what I'm about to do. Yeah, and that's perfectly perfect. 0, 25, 50. It's the cautionary tale more than anything else, because the number of people who have screwed up just on this problem, I can't even. It's astonishing. And you get your graph, and based on your scale, I mean, I went by 25s. You can go by 10s, you can go by 5s, you can go by whatever makes sense to you. Just bear in mind that based on your scale, you may come up with something that doesn't look very much like what the calculator displays. How can you make it look like what the calculator displays? If you go into the window, it gives you where it's starting and stopping and what it's going by. So if you pick something that's kind of near these values, so something a little short of the 55 and a little north of the 84.4, then you're going to be good, all right? So then you think about a reasonable scale. At that point, do you want to go by 25s? Do you want to go by 5s? Do you want to go by 10s? I leave it up to you. You can go by 1s if it makes sense to, but that would be enough. So what I have here and here is enough for full credit. But again, knowing how to identify outliers is very important, because when you get to a question that asks you to do that, it could be a combo question. The way I have it structured here, it could be slightly different. It could merge the two. So how would you figure out outliers by hand? Well, you don't want to. I mean, I'll write the formula on the board, but I don't want you to do it that way. You want to do that? Nah. I mean, it's not terrible, but selecting the modified box plot is going to actually just flat out tell you what those values are. All right. So let me steal a little bit from my answer key. That's not my answer key. From the internet. I'm not looking below. I don't want to see the answers. I mean, I made the answer key myself, but I just want this information. And then I'll show you for class 1, for example, the usual, unusual values, and then the outliers, because it's just a slightly smaller data set. But instead of using that formula, we can use this technique to modify Boxplot. Right, so we'll get this data in. do a quick double check. Always the double check. I mean, I think I'm not telling you something that you didn't already, or I'm telling you something that you didn't really need to know because you were doing it anyway, but I don't think I can say it often enough. Because pretty much everything I say is the number one cause of error. This really is the number one cause of error. This right here, data entry. All right, so to get these numbers, my mean and standard deviation, that's your StatCalc 1. StatCalc option 1. Now, just be careful with this, this menu, because any error that you're going to get in this process is coming right from here. This was set up for some other problem, and it held on to L2 as my frequency list. All right, because at some point I must have put in a frequency table. This is not a frequency table. This is a raw list of data. My list is in L1. I don't have a frequency list, so I can leave that blank. And then hit calculate. All right. So mean, standard deviation. Now, if I were to use the formula to come up with outliers, I'd scroll down and get all this information. But again, I don't want to do that. All right. So I have my data in. Let's worry about unusual values first. All right. Unusual values fall outside of the interval x bar plus or minus 2s. All right. So 2 standard deviations away from the mean. All right. Now, the calculator understands x bar, but it understands s as sx, s sub x. So that's how I'm going to note it here, s sub x, little tiny x.
That's okay.
Yeah. The reason I'm mentioning this is because if you want to use the vars menu to get these values, it would be vars stats, or statistics is how it's represented. Statistic, and I was over statistic, CS. All right, it's a clever little technique that allows us to avoid rounding issues. All right, so vars statistics is option 5. I have an x bar, which is option 2. I would first do a minus, then 2 times vars, option 5, then choose the sx, which is option 3. All right. Again, the benefit of that is I don't have to worry about losing that half point, that aggravating half point that we've all lost at some point for nonsense. You go through your test paper, you're looking over, okay, I didn't know how to do that one. I understand that. I didn't understand that. Wait, because I put a 0.4 instead of a 0.3, I lost half. F word.
Can you go back to that? So I was writing down.
Vars statistics. And then once you get there, you'll see what you need. You have the x bar and the sx is what we're going for. All right. So, and this relies on you doing the calculations first because the calculator needs to know what x bar and sx are. But once you've done this stuff, then it knows it's stored in there, and I can hit enter, and I get that. All right. Now I need the x bar plus 2s. So what do? Hit the up arrow, recall that function, go back and change the minus to a plus. And now I have my interval. All right. So we're looking at 44.511 approximately, comma 99.018. 0184 actually. We're going 3 significant. All right. So what I would do at this point is look at my information and see if there's any value that falls outside of that interval. All right. But I'm going to table that for a second because the next step is going to figure it out for me. All right. So I'm going to do the modified box plot. So second y equals, so same idea as number 1. Turn the plot on if it's not already on. Go down to the one that has the box plot that has the 2 little dots and hit enter. Then do a zoom 9. All right. So this is the modified box plot. It's surprising because you expect it to look different. But what this is telling us is that there are no outliers. There are no outliers because there are no straight points in the modified box plot. That's all I need from you. If I ask you, here's a data set, tell me if there are any outliers, I don't even need the picture. What I need is, yes, there are outliers because there are straight points in the modified box plot. No, there are no outliers. No, there are no outliers because there are no straight points in the modified box plot. That's all I need. I don't need the picture. I don't need anything else. But this also helps me address this because, sometimes we don't pass the eye test. You look at the data set, and as much as you peruse it, you can't seem to draw the appropriate conclusion. So I'm going to hit trace on this, and I'll see that the minimum value in this data set is 47, and the maximum value is 93. All right, so that tells me that there are no unusual values because my smallest number, the smallest number in this data set, as shown by the box plot, is bigger than the smallest usual value, and the biggest number in my box plot is smaller than the largest usual value. So there's nothing in this box plot. Like if I were to draw a number line to represent this interval, the entire box plot would fit in that number line. All right, so that's enough for me to say there are no unusual values. If there were unusual values, I'd have to determine what they were. That could be a little trickier. But, I mean, it's a pretty safe bet. I mean, it's more than safe that if something showed up as an outlier, that it's definitely going to be an unusual value because outliers are extreme values in a data set that are so extreme that they shouldn't even be there to begin with. All right? So that kind of translates to beyond unusual. All right? So you have unusual and then way unusual. All right? So they're definitely in the category of unusual also. All right? So you would do the same thing with the second data set. Put in all that information. Right? Run the calculations the way I did. X bar plus or minus 2s. Determine that there are no unusual values just by looking at the data set or looking at the box plot. All right? So it would essentially be the same thing. Most everything else on the test is procedural, but number 3 is one of the remaining questions that still has a little bit of, you want to do it on the calculator and this is how you do it. So it's another situation where we want to type the data in. I mean, it's not overly lengthy, so it wouldn't be too crazy. I stayed away from questions. I mean, the first couple of questions on the exam, I mean, you can look, it's the same, essentially. It's got the same structure. I have a somewhat lengthier data set, like 20 values and like 15 values, something like that. And then after that, it's minimal in terms of what you have to type in, right? So it should have a similar feel when you take the final. It shouldn't be like, oh, this is completely different from the review. My Calc 2 students on Monday are going to have a different experience. Like, whoa, what was the point of that review? It's nothing like the final. Well, that's because it's a different course. It's not a procedural course. Like, score 1 for statistics. Okay, so data points. All right, double check. All right, data's in. All right, determine the equation of the line of best fit. All right, stat, calc. You have two options that say or allude to the concept of a line. Option 4 and option 8. Linreg ax plus b, and then linreg a plus bx. There really is no difference in the outcome. You can see that one has the x after the a term and one has the x after the b term. They both give you equivalent relations. I prefer option 8, so that's the one I go with. But it's not going to make a difference. If you go 4, you can go 8, it doesn't make a difference. Like every stat textbook in creation goes with option 8, which is why I kind of default to that. All right. The key ingredient here, regardless of which option you choose, because the whole idea here, and we talked, I know it was a long time ago, it was back in September. The whole point is for us to not actually have to manually work with the equation. Right? I don't want to have to solve this equation by hand. I want the calculator to do all the work. So in the end, it's not going to matter whether I use StatCalc 4 or StatCalc 8, as long as I don't screw up this step right here. Store reg EQ. Store regression equation. All right. We're going to hit alpha, then trace, then y1. All right. Because you're going to store that equation in as y1. Vars y, vars function y1. Yeah, it takes you a couple more keystrokes, but you get to the same place. That's all that matters in the end. Then hit calculate, and you get this display. All right. This is all we need. You might have the r and the r squared. That I don't have it because some clown turned my diagnostics off. I don't know why they would. They didn't seem to reset anything else, so it should still be on. Turns out we're not going to have to worry about that for this test anyway. So if you have the r squared and the r, your calculator is set up appropriately. Mine is not, but as it turns out, it's all we need. All right, so if we get this down on paper, if you're worried about, if at any point you're worried about rounding, write the whole decimal. I won't take off if you write the whole decimal. I will take off if you round, if you decide to round and you round incorrectly. Okay? So that's my promise to you. All right, so y equals, just follow the model, a plus bx. The a value, 120.1898734. I'll write the whole thing. I'll practice what I preach. Plus 28.53797468 x. All right, so just following again that model, y equals a plus bx. All right. Also, benefit of writing an entire decimal is that I'll lose interest very quickly. And so if I've lost interest, then I'm not going to be looking to take off points. I have a very short attention span, as you been able to tell throughout this semester. I want you to either round it to 3 significant digits appropriately, but if you feel like that's not something you're going to be able to do, then write it off.
The A value, if you were to round that, where what would it be? I mean, that.
This would actually be 1.9.
And it's for 2.
Yeah, well, technically 190.
Okay.
So.
I was getting something like that because it's the 9 kind of area.
Yeah, but I'm supposed to have 3.
Yeah.
Yeah. And so this would be a good example of a case where it's like, I'm not sure, I don't want to take a chance, I'm just gonna write the whole thing. All right, so part B is our payoff here. Right? Predict the points against if the number of losses equals 10. All right, so the number of losses, those were our X values. The points against are our Y values. So this is saying figure out Y when X is 10. So what is Y when X is 10? In function notation, back in the day, college algebra, pre-cal, any course like that, we would write Y of 10. The benefit of knowing that notation is because I can now use a calculator and get the Y by hitting alpha trace, Y1, or you could use your vars, Y vars, if you like. All right. The idea, again, is when I hit Y equals, that entire equation has been stored in for Y1. So I can evaluate that function for any X value. All right. So if I hit alpha trace Y1, open some parentheses, type in the 10, close them up, and hit enter, and it'll report back the correct answer. Yeah. So that whole store regression equation, that was the key. By putting the Y1 in there, it allowed us to do this step. If we didn't do that, then our next move would be to actually replace X with a 10. So multiply this decimal by 10 and then add it to that. Not crazy. I mean, it's a linear equation. It's doable, definitely. But, I mean, that's that. Some people like to go to the table to get the value of 10, but I don't like doing that because what if I were to say the number of losses equals 3,000? Something that's not easy to get to in the table, or even some situation, some scenario where it requires you to go decimal form. Like if X is equal to 2.18, it's not coming up in the table, but it would come up using this technique. Number 4, that's knowledge, general knowledge. And there's your general knowledge. This I wrote like 3 years ago, and I think I've been copying and pasting it ever since. Yeah, just copy and paste. So write it on your index card. And copy and paste. All right, 4 conditions that must be satisfied in order for a distribution to be considered vital. I don't know. This is my secret way of getting you to memorize these 4 rules by making you rewrite it as many times as possible between reviews, tests, final exams, whatever. So that 10 years from now, if somebody asks you, what did you learn from statistics? Fixed number of trials, fixed probability, independent outcomes, and 2 independent events, 2 outcomes. And that's the only thing you remember. You don't remember anything else. Oh, that and the guy was funny. 2 things. Yeah. All right. So that should be it. I want to make sure I'm not lying. Oh yeah, there it is. No, exactly the same question. No, exactly the same. Yeah, I'd like to prove to myself at least that I'm not a liar. I don't want to. tell you that something could be there, then it's not going to be there. A coin is tossed 5 times. Find the probability of getting at least one head. All right. So there was the rule that we spent. I mean, in the time factors or scales that classes that meet only once a week are based off of, it seems like a 5-minute period, like a month and a half ago. But really, we spent a good 45 minutes on this topic, but it doesn't seem like a lot in the grand scheme of things. All right? They're just kind of a drop in the bucket. But the rule is at least one, in this case, heads, would be 1 minus the probability of not getting a head at all. So no heads. The idea being that if I could figure out the probability of not getting what I want at all, the opposite of that would be exactly what I'm looking for. All right. Now, flipping that coin 5 times. So if I'm not getting heads, I'm not getting heads 5 times. So that would be 1/2 to the 5th power. All right, because I'd be getting a tails and a tails and a tails and a tails and a tails. Each one of those has a probability of 1/2. So 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So you're multiplying 1/2 by itself, a total of 5 times. That's the same as 1/2 to the 5th power. All right. Now you could do this in your calculator, one-stop shopping. You could also, I mean, the numbers aren't bad here. This is 1 minus 1 over 32, which would be 31 over 32. But again, the calculator will do it for you, so why not? Why not let it do what it's made for? All right. So decimal form is fine also. Really is up to you. Oh, that's alpha y equals. You select the n over d button or option.
You actually want that rule be at least one each.
In this case, you need that rule, yeah.
I can,
Oh, okay, cool.
but
All right, number 6. So this is a multiplication rule, probability situation. I mean, they're both multiplication rules, but this one is a little bit more in your face. It should be very similar to one from a previous test. I'm pretty sure that's where I got the diagram. Die is rolled in a geometric figure is selected from the sample space below. Right? Probability of not rolling a 3 and not selecting a triangle. Right? So probability of not getting a 3 and means multiply. Probability of not getting a triangle. Alright. So that little tilde means not. Although the way I make them, they look like N's. So there you go. Not a 3, not a triangle. We're looking at independent events because the outcome for rolling a die will have absolutely nothing to do with the outcome for selecting a geometric figure. All right, so number of ways I could not get a 3 when I roll a die. How many ways can I roll a 3? On a 6-sided number cube. 1, so every other way would be not getting that particular outcome. Not getting a triangle. So we have 12 outcomes here in total. We have a triangle here and a triangle there. I don't want those. So 10 ways in which I can get something that I do want. So 10 out of 12. You do straight multiplication here. It's not been discussed ad nauseum, but it has been discussed, the idea that I don't care if you reduce your fractions or anything. So you're not losing credit. Multiply across, get 50 over 72, and call it a day. Right? If you want, you can reduce, because it is 5 over 6 times 5 over 6. To give you 25 over 36, which you can get by reducing this or by reducing that. But it's extra work. I mean, it's not crazy extra work. It's not going to take you a day and a half to figure that out, but it's another step, which is another opportunity for you to mess something up. I know I'm a little pessimistic about this right now, but you know, like anything that you do that's extra, that's not necessary, it's dangerous because you're opening yourself up to evaluation. If something is not required and you mess it up, you're still on the hook for its correctness. All right. So extra steps that you include, if they're wrong, you're losing points for them. So don't include the extra steps. It's very dangerous. People lose points for that all the time. Number of possible rearrangements of the letters of the word Play-Doh. All right. This is a strange one, but the key term there is, I mean, it's rearrangements, but it's arrangements. Arrangements is another way of saying permutation. I have 5 letters that I need to rearrange. All right, so that's, I mean, if you want to think of this as people being lined up, this would be the case where I have 5 people and I need to determine the number of ways I could put them all in a line, the number of different arrangements. All right, so any of the first, or any of the 5 people could occupy the first position. In this case, any of the 5 letters. Plato. Any of the remaining 4. So let's say, for example, this is not necessarily the case, but let's say, for example, the first letter was an L. Then we'd have a Pato, 4 possibilities. Maybe the third letter, or the second letter was an A, making 3 possibilities, and then at that point, hopefully you see the trend, 4, 3, 2, 1, giving you 120. Or you might look at it and say, okay, I'm taking 5 things, 5 at a time. So I'm arranging them so that there are 5 things per arrangement, in which case you go to the calculator. This is the nicer way, because if I give you a bigger word, like not Plato, but like sorcerer, you know, like, I don't know where. You want a shortcut. You don't want to have to do it this way. So math, so yeah, I put in the 5 first, then math probability, option 2, the NPR function, and then the 5 again. And then we get it. This is going to be the better way, because this way allows you to just really count up the letters in the word. I'm not going to give you any repeated letters in the word, so if you just count up the letters in the word, then it's just that expression. So if there's 7 letters, it's 7 through 7. 20 letters, 20 through 20. Go to your calculator. It's math probability. And then pop it in, and you get the answer without having to show any additional work. All right, number 8 was a contingency table. So first question, well, the first group of questions. One individual is selected at random, find each. Probability of a cocaine user given that the person is in the age group 26 or older. So the given component is the area that you're working. So you're not considering any other part of the table except for the part that is the given. So from this highlighted column, we would make the determination of what is the probability that a person is a cocaine user. All right, so I'd look at cocaine users and the total. As opposed to part B, where it's saying, what is the probability? There's no conditionals here. What is the probability of being a marijuana user? All right, well, I would just, in that case, need to know how many marijuana users there are. Not more marijuana than everyone else. Anyway, total, part over the whole. I do need some updated data. So that could be a typo bonus opportunity for someone because you've seen this kind of problem repeatedly, right, from old tests and things like that. But it's from 2002, and since marijuana, for example, has been legalized in a lot of different places, these numbers could be vastly different. So if somebody's still in the market for some bonus opportunities, that could be something that you could look into later on. All right, so just some updated data. Just find a source anyway. You don't even have to compile it into a table. Just give me it, because I have a link here. It could be even like a more updated link. Just see if you can find a link for me that I could use to make a new table. What's that? And email it or remind it to me. Okay. 2 individuals are selected at random without replacement. Find each. Right. So cocaine given that we're in the 26 or older group. Well, it's 2 individuals without replacement. Right. Well, that would be the case where we're finding 2 probabilities. The first one, if they said 1 individual was selected at random, it would be the same as our answer for part A. Now what they're telling us is that we want to get another person selected at random without replacement. So from the table, I did my random selection. I got a cocaine user that was from the group of 26 or older. I was successful in getting, I did my random selection, and that's what I got. That's what I was looking for, that's what I got. All right, so we always assume success on our first try. Without replacement, which means I'm not putting them back in the pool. What that means is that I have 1 less cocaine user in that group, right? And that group now contains 1 less individual. All right, so we're just actually taking our answer for part A and decreasing it by 1. So, and the same idea for D, we had 4293 when it was just a single individual selected at random. Now if I want a second person, a second marijuana user selected at random, well, there's 1 less marijuana user. And there's 1 less person in total. All right, so you just multiply these together and you get your answer, which I can just steal. That iPad app really makes my handwriting look good.
So you want to multiply across or?
Multiply across, yep. Now the last 2 problems, let me just snag them from the answer key and then just talk about them, because it's really, well, talk about them in the extent that I'll show you where the information came from, and then we'll discuss the conclusion also. The last one I think is pretty straightforward though. Just do that. No, a little smaller. Oh. could just edit that out, but okay, good enough. The last, I'll copy it, but I think the last one is a little obvious. Hopefully, when you really think about it. Because they say it right in the problem. Alright, so I'm just looking for where they say it right in the problem. Yeah, previously, who had previously purchased Gerber products. Alright. So, yeah, I mean, it's like, what's wrong with this experiment? They ran an experiment. And is it even an experiment? I don't know. You know, I mean, it kind of is, because they're giving them Gerber and beech nut brand sweet potato baby food and then having them rate it. So they are imposing a treatment, but it's obviously not going to be a good study. But the thing that makes it specifically wrong is because it's going to be biased based on the fact that you're only sending it to people who had previously purchased Gerber products. Okay, why did they? And we don't even need to know the answer to the question. Why did they purchase the Gerber products to begin with? Okay. The fact of the matter is, you have a subset of the population that only purchased Gerber products. Like when I was buying diapers, for example, we always got Pampers. We never got Huggies. Why? Because somebody told us that Huggies were shit. Yeah, I was like, but that's all, like, I never tried them. So if somebody gave me like a sample, like here's some Huggies and here's some Pampers, and then told me to rate them, I'd be like, thanks for the free Pampers. I'll complete your survey. Awesome, awesome, awesome. Garbage. And I would have even tried it. You know, so that's, I mean, a pretty solid example, hopefully. I mean, it's definitely anecdotal because it's just off the top of my head, but it's hopefully some difference. But number 9, that's your hypothesis test question. It's depending on, you know, whether or not you could find an appropriate function within the calculator. Right? So in this case, you have a bunch of people surveyed, 193 strongly agreed with the statement. Then a bunch of other people were surveyed, and 61 agreed with the statement. Right? So you have a number of trials and a number of successes for 2 separate categories. Right? So that's an indicator that we're dealing with a 2 population proportion test or a 2 prop Z test. Right? Now, it's asking whether or not the percentage or the proportion has dropped. Dropped would be that, you know, it got smaller, right? So you went from high to low, or higher to not as high, you know, but there was a decrease, right? Which would show that the value before is more than the value after, right? So once you have that idea in mind, you go to your calculator, your stat test, option 6, and you see that it's structured the way we need it to be. Type in your 193, the 1484, the 61, 61, 10, 13, and then a greater than, and then do your calculation. All right. The issue here is, well, what if you couldn't identify it as a 2 prop Z test? And you use your omit on another question, right? So that's an important strategic component, right? Well, what do? Or what you do is you start going through different stat tests until you find the one that lines up with the information that you have, all right? But that would require you to have a sense of the information you have. So go through your problem and write down, try to organize it, categorize it. Identify your n's, your x's, if you have an x bar in there, identify them, so that when you do come to the function in your calculator, it's easy to see whether or not it matches up with the data or the information that you have, right? And so If it does, then you type it right in, go to calculate, and in a lot of cases you don't even know why. You just know that this is the one that works, right? And for this kind of situation, we'll take it, all right? And then we get our p-value, which is this 7.21 business. It's in scientific notation, which means you got to get the entire decimal down. I wrote times 10 to the negative ninth, but you could write e negative 9. That's perfectly fine. All right. That tells us, you have different? Okay, one sec. I'll take a look. So the p-value is less than the alpha value. So that's telling us to reject the null hypothesis. And that would be the conclusion that goes along with it. So the first sentence addresses the fact that we're rejecting the null. The second sentence addresses the question asking, in this case, of the proportion that dropped. Oh, you have a non-equal symbol. You want a greater than. Nice. Just in the head. That's usually what happens. No problem. Okay, so that is the review. So take a couple minutes. Let me kill this.